Hello everyone, my name is Timothy Lee Grant, and today we are going to do something a little bit different than what we normally do here on this channel. Previously I was working a lot on a project that was focusing on trying to learn the key concepts within back-end software engineering in the context of, doing a project to try to understand all of those important concepts. And I was using a project with JavaScript, okay? We're still going to be continuing that project. We're still going to be moving forward with it because there's a ton that we need to still learn. And I still have a lot of ideas about how I'm going to make it more complex, how I'm going to try to find all of those important concepts within software engineering, specifically back-end software engineering. But I think I'm going to start another project. So I'm going to have two projects going on kind of at the same time. It also gives me a little bit of variety as well. So this one is going to be Java. So not JavaScript, but Java. And the reason is because I keep hearing how important Java is. I keep hearing it over and over and over and over. So I'm like, okay, all right, I heard you. I heard you. Java is important. Let's do it. So, again, just like with the project in JavaScript, the point of this project in Java is very similar. So, it's not to be extremely impressive, right? It's not to be useful. No, we're not trying to build an impressive project. We're not trying to build a useful project. All we're trying to do is build a project that allows us to play with the different concepts in backend software engineering. So, what are the important concepts within this field, right? And how can we use this project to kind of play with those ideas and understand those ideas better? That's what we're trying to do. And that's how we're going to be moving forward. The second thing is this is not a intense thing, right? This isn't we're gonna go. No, no, no. We're having fun. We're trying to enjoy it, play with it, okay? Play with things, have fun with things, and figure out what don't we know. And the third thing to mention is obviously I am not a professional. I'm an electrical engineer. I'm not a software engineer. I'm an or more specifically, I'm an embedded systems engineer. So I got my degree in electrical and computer engineering. Okay, and then now I work as a firmware engineer or embedded systems engineer. But I'm in the hardware department, and a lot of my work is related to more of kind of like the embedded systems, just very much talking to electrical components and stuff like that. So I'm not a software engineer. I am an electrical engineer. And so that's kind of the point of these projects is okay, well, I enjoy software engineering. I enjoy back-end stuff, and how do we get there? What are the important concepts? What do I need to learn for myself to be able to get to the destination that I'm hoping to be able to get to, right? And I'm creating these YouTube videos as a way to kind of document my process and progress, but also kind of showcase those important concepts as I find them along the way. And hopefully that's also helpful to you guys as well if we're able to go kind of on this journey together. So that's kind of what's happening with this project. So I'm going to be continuing uh, this Java project, and it's going to change over many iterations, right? Right now, what we're going to be doing is first off, we're just trying to understand what concepts do we want to hit. I have no idea what I'm going to be doing with this Java project. And uh, likewise, with the JavaScript project, we're going to be continuing to move that one out and get more complex, more hit a lot of those points. I'm going to be going like in both projects. So let's kind of just I will make myself a little bit smaller and let's start. Okay, so I have this blank project here, and let's go to ChatGPT. Let's ask it what it wants us to, or what it thinks that we should be doing. And the same way that I work with my JavaScript project, what I'm going to be doing is try to get something that works. Okay? Get anything that works. Then, once we have a working copy of something, okay, now we know that it's correct. Now we can go in there and kind of investigate, back engineer what we have and say, how is it working? Why is it working? What's going on here? And start to investigate those concepts and ideas. So, with this project, I guess maybe I should start to articulate, like, what am I trying to do? So, it kind of gets to the point where you don't know what you don't know yet. Okay? And so I know that number one, I keep hearing that Java is extremely important. So therefore, I want to get familiarity with the language. That's number one. So we're going to obviously be able to do that just doing a Java project. Okay. Well, what else? I know that Spring and Spring Boot is extremely important. I know I've also been hearing unit testing, right? Like Java has a really good unit test a framework, I guess you can call it. So unit testing, end-to-end testing, all of those testing things that are important within a project. Okay, well, I want to integrate this into my project as well. Some other things like a CI/CD pipeline. Okay, so I'm trying to take all of these concepts and figure out how I can fit them in to this project. And as I said, it's gonna change. This is just kind of the first iteration of it, and as I start to play around with things more, I'm gonna be like, yeah, let's change things up, right? Perfectly normal. So yeah, let's just come here and what do we want to say? I am wanting to about learn Java to help me develop my skills as a backend software engineer. Okay, just start this. All right, so great choice. Java is a powerhouse for backend development, widely used in enterprise applications, cloud computing, and web services. To get started, here are some great tutorials. Okay. Can you give me some starter code in Java? Okay, let's just see what it suggests. All right, so greets user by name, counts 1 through 5. Is this like multi-threaded or is it just like so? Maybe we'll do these later. Let's just try to get something working. So I'm gonna come here. What should I call it? Test.java. I'm guessing Java is the extension that I should be doing. Okay, so I have this here. There's red stuff here. What's wrong? Why am I getting an error? Okay, so how do I run this code? Okay, so I'm not using. Okay. If you haven't already, do this. Okay, so do I have the JDK? Extensions, Java. Oh, Maven and Gradle. I know that that's also big, so we're going to be hitting that as well. So Java. New terminal. Okay. going on there? And who do you think you are? Okay. So we got this. All right. Okay. Looks like your terminal isn't finding... Oh, okay. Hi, come on. That's really annoying. Come here, new terminal. There we go. Okay, so I will run that command again. I think what's going on is the name is incorrect. Okay. So I have this, and then I called it test.java. Okay. Awesome. So we got a different error. So we're making some progress. Okay. That's a classic file name. Since your Java class is declared as here, the file name must match. Okay, so apparently this needs to actually match the file name. That doesn't make any sense. I don't know why that's the case. But we will go through with that and change it. So starter Java program. Okay. So again, just right now trying to get anything that works, and we're just, okay, we got a new error. All right. All right, let's see what happens. It looks like your terminal can't find test.java. Yes. That would be a starter Java program. Here we go. Hey! Something happened. We didn't get an error. Okay. So, what actually happened? And I see something coming up here. So I have a .java and a .class happening. Okay, so should we look through this code now, or... Okay. Check for type. Okay. I think I got it now. What should I have seen happen? Okay. Is there like a print statement anywhere? System.out print. So apparently this isn't actually working though, because we're not getting... So let's just see what this does. So we have this main function. Oh, I guess I have to pass in some arguments. So scan. I'm guessing this is like CN within C++. Okay, system out. So this is like printing. Scanner. So it gets input from the user and then prints it and then does a loop. Okay. So let me run this again, and then what did it want? Arguments of... What arguments? Args. I'm not seeing any. Okay. Yeah, it didn't do this. It just ran with no input or output and gave me a new line, or not new line, but like relinquish control to the terminal, and relinquished control to the terminal. Yes, exactly. So, no output. Ensure that your code here statements. If you're using an IDE, check if the console is visible. Skipped. Okay. Saying to do it like this. Ah, here we go. Okay, so Timothy Lee Grant. There we go. Enter number 4. 4 is even. Okay, so the world is in order now. We got something that works. So a few questions that I have is this one, Java C, and then the program name. What is Java C? That's a question that I have. Then I can just do Java. Okay. Second question. What is this class up here? Like, this was just created. I didn't create that. What's going on there? I created this one, not that one. Okay. And then, thirdly, I kind of want to go in here and figure out, like, okay, well, most of this just kind of looks like syntax differences between. If you know one programming language, the syntax is not really what I'm concerned about in this series in this project. Like, I'll learn the syntax along the way just by dealing with it, but I'm trying to see if there's any kind of like fundamental concepts that I don't understand. Obviously, I see like public class, so it's very object oriented is one observation. Okay. So let's try to figure this out right here. Like, what is Java C program name dot Java, okay, and Java, okay. What is the difference? Okay. All right, the difference between Java C and Java is fundamental to how Java programs are executed. So this Java C and then program name. So Java C is the Java compiler. Okay, so I first needed to compile the project. Okay, it translates your .java source code into bytecode. Okay, the .class file, which is up here. Okay, there we go. So that's why it was created. When I did the... Oh, which is also why I didn't get any output, because I was just compiling it, right? Like, of course I'm not going to get any output because I'm not executing the program. When I did this one, I'm just compiling this Java program, okay? And that creates the .class file. Then what I did is Java, and then, oh, notice I didn't even put the .java there. So it's just start Java program, which I'm going to guess what's happening here is the compiler or the operating system is going to be searching for a class file with this name and then executing it. So, but I mean, this kind of just looks... It's the same thing, though. Like, it compiled it into something that looks identical to it. Like, what's it? Okay. Anyways, so this generates a class, which is the compiled version of your code. Okay, so Java program name execution. So Java is the Java interpreter. So I know that there's what, like a JVM, Java Virtual Machine, or something like this. And I know that that has something to do with the way that Java works. Not sure how that kind of plays in, but we'll think about this. All right, so it runs the compiled bytecode .class file on the virtual machine. JVM, here we go, Java Virtual Machine. So it runs this class on the Java Virtual Machine. Okay, so this executes the program and produces an output. Okay. When I look at the .class file, it seems to be the exact same thing as the .java. It doesn't look like a, what is it in C, right? Like you do GCC compile and you get a .o, like a GCC compiled C program, which is completely uninterpretable. I don't know if I got that. Anyways, to a human. All right. So that's an interesting observation. Java's .class file contains bytecode, which is an intermediate representation. Bytecode? Like, does that look like bytecode? Isn't bytecode more like machine code? Like, load register 25 into register 12, add register 3 and register 4. Maybe I don't know what bytecode is. Okay. Well, it's not as readable as .java. It's still more structured than a fully compiled C program. So Java compiles bytecode, which means it's interpreted by the Java virtual machine rather than directly by the CPU. Okay, so the Java virtual machine is the thing that's actually doing the interpretations. Okay. Unlike C, which compiles directly to machine code, binary instructions for the CPU, Java bytecode is platform dependent. Or independent. Okay, so C gets translated to the instructions which are for your specific computer and operating system and all of that. Java is not the same because it gets compiled for the Java virtual machine, and that Java virtual machine can run your .class file from any machine. So I can take that .class file and put it on a Windows computer. Since I'm on Mac right now, I'd put it on my Windows computer and I should be able to run it as long as I have the Java virtual machine. I think that's what it's saying. So how C compiles differently. C programs are compiled using GCC or similar compilers into machine code, which is specific to the CPU's architecture. Yep. Machine code is binary zeros and ones, completely unreadable to humans. Yeah, that's kind of what I'm meaning. Like if you try to open up a .o file or any of those, you're just going to be like, okay, well, I think a lot of machines don't even allow you to open it up really because they're like, no, this isn't for you. That's not yours. Okay, once compiled, a C program does not need an interpreter. It runs directly on the hardware. Okay. Want to see the difference? So try using Java decompiler like Java P to inspect your class file. Let's do it. Let's see what this does. Whew. Nice. Ah, here we go. Here we go. So this is kind of okay. So we want to do an immediate load here. Okay. Go to, so I think that this means like jump, right? Get static. I'm not sure what get static would be, but I recognize some of them. Immediate increment, so we're incrementing what 3 by 1, I guess maybe. LDC. Anyways, we're not trying to learn embedded, or it's not really. It is embedded. It's assembly. Sorry, we're not trying to learn assembly. So, where are we going from here? All right. So we looked at that. Let's try to ask it like how do you get a Java program with multiple files? How do I get a Java program with multiple files? All right, so uh, programs often consist of multiple files to keep code modular and organized. Here's how you can set it up. All right, so let's say you have two classes, main.java, okay, which looks like this. All right, and helper.java, which looks like this. Compile all files together, so we do that Java C, the compiler, and then put in those two compiler things, which I think Gradle and Maven are the ones who actually normally take care of this process. But right now we're just learning the basics, so we're going to do it by hand and then later go on to the Gradle Maven kind of stuff. This compiles both files. Okay, cool. To execute the main class, I do this. All right, so let's kind of do that. Let's come here, and now I can do main.java, okay? And it automatically created this main here. Okay. And it doesn't like that because the names are different, you see? All right, so now what's it not happy about here? We'll see. We'll see what happens. It's fine. Main. Rename. Main. Okay. Are you happy now? Good. So it doesn't like this helper. So equals new helper. So I'm guessing this is how we actually do the import. So I'm going to come here and do what helper dot java. Okay. And come here, helper, which is capitalized, and then we have this. Okay. So now just plug that in there. Okay. Now we need to Java C compile main.java and helper.java. Okay, now we should get two classes. Yeah, right, no. Where are they? Main class and helper class. Okay, so now what we should do is be able to compile or like run it on the Java virtual machine. So to do that, we do Java, say, hey, Java virtual machine, do your thing. And do your thing on what? Do your thing on main. So main with no arguments. There we go. Okay. So I'm going to get rid of you and I'm going to get rid of you. Okay, so I want to know how it does its imports. It worked, but now I am trying to understand how Java does import statements. It doesn't seem like it does them the same way as other languages I know, such as C, Python, or JavaScript. Okay, so you're right. Java handles imports differently than languages like C, Python, and JavaScript. Here's how it works. So, how Java import statements work. Java's import statement is used to bring in classes or entire packages so you can use them without specifying their full path. So, yeah, this is more of like what I'm used to is like import and then a path, right? So if you need just one class from a package, you can import it like this. So what would this be? Java utils array list. Okay. So then I can have array list, which is kind of like a data type, I'm guessing, of strings, and it will look like that. Okay, so without the import statement, you'd have to use fully qualified names. So oh yeah, that looks ugly. Importing an entire package, so I can do dot star again, like that's nothing revolutionary. A lot of languages do that as like import everything. So this brings in all classes from Java utils but doesn't import sub packages. Java allows importing static methods or variables so you can use them without referencing their class. How Java differs from other languages. So C does the hashtag include, yeah. Python just does import. JavaScript does import, and then the function from module. Okay, so Java's import is completely or compiled time only. Or compile time only. There we go. It doesn't dynamically load modules like Python or JavaScript. Instead, it tells the compiler where to find classes. Okay, so all right, whatever. But we didn't even have an import statement, though. Okay. But here is the entire program you gave me. Notice that there is not a single import statement in the file, but I was still able to access the, what was it called? Helper constructor. Okay. So the reason you're able, or the reason your program works without an import statement is because both main.java and helper.java are in the same package by or the default package. Okay, what is a package? What does that mean? Okay. So why no import is needed in Java if two classes are in the same package or default package, they can freely access each other. Java only requires an import statement when accessing classes from a different package. So, example where import is required, if you move helper.java into a package like utils, you must import it. Okay, well, let's kind of do that. Like, okay. give me another Java file that I would need to use the import on and show me where to place it. Also, what exactly do you mean by package? I don't know if AI can kind of get the context or the hint if you say like exactly all capitalized. I don't know if it does that, but well, okay. So great question. What is a package in Java? A package in Java is a way to organize related classes into a directory structure. Think of it like folders on your computer. So it helps avoid name conflicts. So two classes named helper in different packages. It makes code easier to manage and modular. It provides access control, so protected members are accessible within the same package. All right, using an import statement. Let's create a multi-file Java program where one file is in a different package and requires an import statement. So I have my main.java here, and I'm going to create a utils folder and have helper.java. Okay, so come here, create this utils, okay? And then within this, helper.java. Now, again, like, hold on, I have helper here, helper there. I'm going to call this helper2. Okay. So now I have helper2. Okay. And this also kind of gives me good practice on playing with things. Like, okay, well, I'm going to change the name. I don't want it to be helper. I want it to be helper2. So let's try to do that. So helper in Java in the utils package. So declares that this class belongs to the utils package. Okay, so this kind of lets it know, like, hey, you're in a different package, helper2. Okay. Oh, another thing that I'm noticing, this one says helper2 and this says hello. So the function does not need to be the same name as the class. Okay, so this is going to bring up another question that I'm having with Java, and that is like, where is this class? Where is it being instantiated? Where is it being run? Like, what's going on here? I don't know if that's a today question or a tomorrow question, but it's a question that I know that I'm going to have to ask. Okay, so now what do I want to do? I want to come here into main and I want to run this. I want to do like import utils dot helper2, right? Oof, why is it red? I don't like it. That's not nice. Okay. Import utils.helper. Did I forget like a semicolon or something? Oh, okay. I was almost about to joke about that, but I think it was actually accurate. Okay. Now I'm going to change helper2 to actually say from helper number 2. Okay. So now I'm going to say new helper 2. helper 2, right? Huh. So utils helper 2 and main.java. Okay. And now I should be able to do Java and then main. Okay. So this is like the type, right? So I'm saying it's of helper 2 class. And then this is the actual object. And then I'm passing, like I'm getting a constructor. I don't like this word here. This is one of the worst words in all of programming. I really hope that's a question I have to ask immediately. Does Java have garbage collection? Okay. That is a yes. Good. I like Java then. Okay. Good, 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 good. All right. What else do I want to do? Can you tell me more about these classes? I am only seeing one function inside of them. Can you have multiple classes multiple functions in the same class? And with member variables, how would this work? I also noticed that I never instantiated the main.java class. Okay, so yes, Java classes can contain multiple methods and member variables. This is actually core to object-oriented programming. I was assuming that we could, right? That would be kind of... Okay, so... All right, the other thing that I'm noticing is that it has private and public, and I'm assuming that that is strongly enforced as opposed to other languages, Python, that everything is just public. Okay, so it is this dot name. So instead of like self, we have this. Okay. Instantiating a class, creating an object. Okay. So we just have multiple different functions here within the class. Instantiating a class, creating an object. So do the new, so we have to say the type and then the new and then person and then pass in those arguments to the constructor. So person here and then public person. So here's the constructor. It takes in 2 arguments. Awesome. So why you don't instantiate main.java? The main class contains the main method, which Java automatically executes when you run. Okay, so since main is static, it doesn't require. Okay. Okay. Um, if I want to make my project more complex, how would you suggest, oops, I go about this? So I'm going to see what it says. I'm thinking maybe what we do is we just try to, I don't know what I want to do with Java. Like what do I want to create? I could play around with the object oriented programming, which is what it's suggesting here, or I could build something. I'm leaning more towards the actual building of something just cuz seems like I can understand the concepts a lot better if I just build something. So, okay, introducing object oriented file handling. Okay, so that's add a REST API. Structure for using packages. So build a medium complexity program that does REST API. So we've been working on REST API in the JavaScript project for a little while now. So now we are going to, I guess, be doing something kind of similar. Um, Maybe this is actually going to be a tomorrow kind of. Yeah, so this let's do this tomorrow. So I think the next video that I'm going to be doing, I'm going to be going through these this uh, mini project, right? The big project is learning Java, but along the way we're going to be doing mini projects. So MANY space MINI, right? Mini projects. And so we're gonna do this mini project, which is just creating. Oh, and cool! It's setting up Spring Boot. So along the way of doing these little projects, we are going to be able to encounter a lot of different random things, and that's the point of this series, the Java series and the JavaScript series, is see what we encounter, learn along the way, have fun, play around, and just enjoy ourselves. So if that is interesting to you, subscribe to this channel. I will be making that video either tomorrow or the next day. I'm in Oregon right now, but I need to drive up to Seattle tomorrow night. So maybe I don't do it tomorrow, maybe it's the day after. Right now I am driving, so I live in Seattle, but I work in Oregon. So, and I'm splitting my time between the two places. So I do Monday and Friday work from home in Seattle. So I do Friday, Saturday, Sunday, Monday in Seattle, and then drive down to Portland. And I live with my parents on Tuesday, Wednesday, Thursday here in Oregon. So tomorrow is Thursday night, so I'm going to be driving all the way from Portland up to Seattle. So maybe we do a video, maybe we hold off until the next day. But, anyways, that's going to be coming up in the next video. And if that's interesting, subscribe. I hope you guys have a wonderful day. I'm excited about both of these projects. I have a lot of ideas for where we're going to go on the JavaScript. I also have a lot of ideas where I want to go with the Java and playing around with different miniature projects. It's going to be fun. So thank you for watching this video. My name is Timothy Lee Grant, and I will see you guys in the next video.